Bismillahirrahmanirrahim. We continue our discussion on number system. And in today's discussion, we will be discussing the last number system conversion. We are going to discuss hexadecimal number system and its different conversions in today's lecture. As we had already discussed different number systems in previous lectures that include 3 conversions for decimal number system, 3 conversions for binary number system, and 3 conversions for octal number system. So a collective of 9 number system conversions have been completed. Hexadecimal number system is the last number system that we are going to perform conversions for. It has 3 number system conversions that include hexadecimal to decimal number system conversion, hexadecimal to octal number system conversion, and hexadecimal to binary number system conversion. So this is the last part of this number system chapter. So let's proceed our discussion and see how we can convert hexadecimal number system to its respective 3 other number systems. We are discussing number system conversions, and this discussion is being carried forward since last so many lectures. As I just said, we have performed a total of 9 number system conversions so far, and there are a total of 12 number system conversions. What we have done so far include 3 conversions for decimal number system, that include decimal to binary number system conversion, decimal to octal number system conversion, and decimal to hexadecimal number system conversions. So a total of 3 conversions for decimal number system. Then we completed 3 conversions for binary number system, that include binary to decimal number system conversion, binary to octal number system conversion, and binary to hexadecimal number system conversion, that collectively make 3 conversions for binary number system. And then in previous lectures we completed 3 conversions for octal number system, that include octal to decimal number system conversion, octal to binary number system conversion, and octal to hexadecimal number system conversion. So a collective of 3 conversions for octal number system. So far 9 total conversions have been completed. And in today's discussion, we will be starting on hexadecimal number system. In today's discussion, we will focus on hexadecimal to decimal number system conversion. So let's see what is the mechanism and what is the technique that can be used to convert a hexadecimal number to a decimal number. Hexadecimal number consists of total 16 symbols that include 0 to 9, total 10 digits, while remaining of the 6 digits are obtained from alphabets. So A to F, total 6 alphabets are used to replace 6 digits, that is 10 to 15. So digit 10 is represented by alphabet A, 11 is represented by alphabet B, 12 is represented by alphabet C, 13 is represented by alphabet D, 14 is represented by alphabet E, and 15 is represented by alphabet F. So a total of 16 symbols are used to represent a hexadecimal number. Hexadecimal number finds its applications to represent the memory addresses of modern computers. In modern computers, the memory is represented using the hexadecimal notations. While the decimal number system is a common number system that is being dealt in our daily life, it consists of total 10 digits from 0 to 9. So this is a common number system, or you can say it is native to human language. Whenever we deal in numbers in our normal life, so actually we are dealing in decimal numbers. Decimal numbers are represented with base 10, but since it is a common number system, so commonly we do not write the base 10, as it is understood base 10 is a common number system, so you may or may not write the base with it. But rest of the number systems must be written with their respective bases. So hexadecimal number system, or any number that is a hexadecimal number, must be represented with base 16. Now let's see what is the method that can lead us from a hexadecimal to a decimal number. Method is written here. We need to multiply every digit in the given hexadecimal number with 16, while the power of 16 must start from 0, and the multiplication process moves from right to left if the given hexadecimal number is an integer part. If it is a fractional part, so the multiplication will move from left to right, and the power of 16 will start from -1. But in first step, we are dealing with a whole number or an integer part of hexadecimal number. So in that case, every digit in the hexadecimal number is multiplied by 16. The power of 16 starts from 0, and the multiplication process moves from right to left. And then we need to add up all the products, and the result is then a decimal number. So let's see with few examples how we can apply this method in order to convert a hexadecimal number to decimal number. Here we are given a hexadecimal number 1D9. You can see D represents a hexadecimal number, as the rest of the three numbers do not contain alphabets. But D here means this number is a hexadecimal number, and D shows 13. But since 13 cannot be written in hexadecimal number, so we replace 13 with alphabet D. So what is the procedure to convert this given hexadecimal number to decimal number? First, we have to multiply every digit in the given hexadecimal number with 16. The power of 16 starts from 0, and the multiplication process will move from right to left. So let's begin the process. The given number is 1D9. That means 1, 13, 9. So we multiply every digit with 16. The multiplication process starts from right to left. So you need to multiply the number starting from right to left. So first digit is 9. 9 is multiplied by 16. The power of 16, as you can see, is 0. Next digit is D, but D shows 13. So 13 is multiplied by 16 and the power of 16 is 1. Last digit is 1. 1 is multiplied by 16 and the power of 16 is 2. After simplifying the powers, this is the answer. 16 raised to power 0 is actually 1. 16 raised to power 1 is equal to 16 and 16 raised to power 2 is equal to 256. After multiplication, the result is this and we add up the products. The end result is 473. This 473 is actually our decimal number. So how you write the answer? Collectively, 1D9 in base 16 is equal to 473 in base 10. So this is how the method is applied in order to convert an integer part of hexadecimal number to decimal number. Every digit is multiplied by 16. The power of 16 starts from 0 and the multiplication process moves from right to left. Let's see another example. Here we are given a hexadecimal number 80E1 and we have to convert it into decimal number. As you know, E represents number 14. As 14 is not a valid symbol in hexadecimal number, so it is replaced or substituted by alphabet E. So now we have to convert this number, this hexadecimal number, into decimal number. The process is clear to you, or the method it must be clear to you now. Every digit in the given hexadecimal number is multiplied by 16. The power of 16 starts from 0 and the multiplication process moves from right to left. So this is the given number 80E1. So we multiply every digit with 16. This is how the multiplication starts. So first digit is 1. 1 is multiplied by 16. The power of 16 is 0. Next digit is E. E shows 14. 14 is multiplied by 16 and power of 16 is 1. Third digit is 0. 0 is multiplied by 16. The power of 16 is 2 and last digit is 8. And 8 is multiplied by 16. The power of 16 is 3. So when we clear up the powers, this is the answer. 16 raised to power 0 is equal to 1. Anything raised to power 0 is equal to 1. And 16 raised to power 1 is equal to 16. 16 raised to power 2 is equal to 256. And 16 raised to power 3 is equal to 4096. When we multiply, the result is this. After multiplication of individual numbers, and when we add up all the products, the end result is 32993. This 32,993 is actually a decimal number. How we write the answer? 80E1 in base 16 is equal to 32993 in base 10. You can see every digit in this end result is within the range of decimal number system. So that is why this number is a decimal number, as decimal number ranges from 0 to 9 and every digit within this end product or end result is within the range of decimal number system. Now if we are given a hexadecimal number that contains a fraction, so how we can convert it to decimal number? Again, a decimal number would contain the fraction. So conversion of fractions to fractions, hexadecimal fraction to decimal fraction. The method, as I just said, is written in front of you. Again, we would multiply every single digit in the given hexadecimal fraction with 16, but now the power of 16 will start from -1, and the multiplication process will move from left to right. The multiplication is the technique, but the multiplication process will now move from left to right, or you can simply say the multiplication process must continue or must start from the decimal point, and the power of 16 will now be -1. At the end, we will add up all the products and the result will be a decimal number. So how it is different from the integer part of hexadecimal number? For the integer part, we followed the same techniques, but the multiplication process is now reversed and the power of 16 has become positive. For the integer part, we multiplied every digit with 16, but the power of 16 is 0. And for the fractional part, we multiply every digit with 16, but the power of 16 starts from -1. For the integer part, the multiplication process moves from right to left, and for the fractional part, the multiplication process moves from left to right. And at the end, we add up all the products, and the result is a decimal number. Let's see with few examples how we can apply this method on some examples. Here we are given a hexadecimal fraction 0.B1, and we have to convert it into decimal number. B, as you know, is equal to 11. Since 11 is not a valid representation in a hexadecimal number, so it is replaced or substituted by alphabet B. So the process or the method says every digit within the given hexadecimal fraction is multiplied by 16, but the power of 16 starts from -1. So let's see how we can apply the method. The given number or given fraction is 0.B1. So this is how we multiply. Here you can see the left side of decimal fraction or decimal point is the integer part, while the right hand side of the decimal point is the fractional part. So the integer part is multiplied by 16, and the power of 16 is 0, starts from 0. The decimal point is replaced with symbol plus. Why? Because the fractional part will ultimately generate decimal points. Now this B1 is the fractional part. So for the fractional part, the multiplication starts from left to right. So first digit that is to be multiplied by 16 is B, but B is actually number 11. So B is multiplied by 16, and the power of 16 starts from -1. Here you can see. Next digit is 1. 1 is multiplied by 16, and the power of 16 is -2. And in this way, the fractional number will move on from left to right. If another number would have been there, that would be multiplied by 16, but the power of 16 would be -3. So after clearing up the powers, this is the answer. (16 raised to power 0 is equal to 1. So 0 is multiplied by 1. And then 16 raised to power -1 is equal to 1 by 16. And 16 raised to power -2 is equal to 1 by 256. So when we perform the divisioning, this is the result. 1 by 16 is equal to 0.0625, and 1 by 256 is equal to 0.00390,625. When we perform the multiplications, these are the results for individual multiplications, and when we add up these products, the result is 0.69140,625. This is actually a decimal number. Now how we write the answer? 0.B1, which was a hexadecimal number, has been converted to 0.69140-625 as a decimal number. Let's see another example. We are given a hexadecimal fraction 0.9D9 and we have to convert it into decimal number. D is equal to number 13. Since 13 is not a valid representation, so it is substituted by alphabet D. So now every digit in the given hexadecimal fraction is multiplied by 16. For the integer part, the power of 16 will start from 0, and for the fractional part, the power of 16 will start from -1. Multiplication process for the integer part will move from right to left, and for the fractional part, it will move from left to right. So this is the given number 0.9D9. This is how we multiply. So this 0 is the integer part, while 9D9 is the fractional part. So multiplication for the integer part moves from right to left, while for the fractional part it moves from left to right. Or you can simply keep in mind, for both the sides, start the multiplication process right from this decimal point. So first digit in the integer part is 0. 0 is multiplied by 16. The power of 16 starts from 0. Decimal point has been replaced by symbol plus. Next digit is the fractional part, and that is 9. 9 is multiplied by 16. The power of 16 is -1. Next digit is D. D is equal to 13. 13 is multiplied by 16. The power of 16 is -2. And last digit is 9. 9 is multiplied by 16. And the power of 16 is -3. After clearing up the powers, this is the answer. 16 raised to power 0 is equal to 1. 16 raised to power -1 is equal to 1 by 16, or 16 raised to power -1, we can write it as 1 by 16. 16 raised to power -2 can be written as 1 by 256, and 16 raised to power -3 can be written as 1 by 4096. So when we perform the divisioning, these are the answers. 1 by 16 has been converted, or it is equal to 0.625. 1 by 256 is equal to 0.00390,625, and 1 by 4096 is equal to 0.00244140625. After multiplication, the individual results, these are the answers or the products, and when we add up these products, the end result is 0.615478515625, which is actually a decimal number. How you write up the answer? 0.9D9, a hexadecimal number, is equal to 0.615478515625 as a decimal number. I hope both the methods are now clear to you, how you can convert the integer part and how you can convert the fractional part. Now we are going to perform a whole number conversion, having a complete integer part and a complete fractional part, in order to differentiate between the multiplication process and the powers. Here you can see we are given a complete hexadecimal number containing an integer part and a fractional part. The number is BCC.10. Here you can see B is equal to number 11, while C is equal to number 12. But since 11, 12 are not the valid representations, so they are substituted by alphabets B and C. What is the process to convert this number to a decimal number? The integer part will be multiplied by 16 and the power of 16 will start from 0. The multiplication process for the integer part will move from right to left. while the fractional part will also be multiplied by 16, but the power of 16 will start from -1, and the multiplication process will move from left to right. Every digit in the integer part and every digit in the fractional part is multiplied by 16. So let's see how we can do it. The given number is BCC.10. So this is how we perform the multiplication. So we start with the integer part. First digit in the integer part is C, but C is equal to number 12. So first C is multiplied by 16, the power of 16 is 0. Another C is again 12, which is multiplied by 16, and the power of 16 is 1. B is equal to 11, 11 is multiplied by 16, the power of 16 is 2. The decimal point has been replaced by symbol plus. So the fractional part, the first digit in the fractional part is digit 1. So it is multiplied by 16, the power of 16 is -1, and then next digit is 0. It is multiplied by 16, the power of 16 is -2. So multiplication process for the fractional part moves from left to right, while for the integer part it moves from right to left. After clearing up the powers, these are the results. Here you can see 16 raised to power 0 is equal to 1. 16 raised to power 0 is equal to 1. 16 raised to power 1 is equal to 16, and 16 raised to power 2 is equal to 256. While here 16 raised to power -1 is equal to 1 is equal to, or it can be written as 1 by 16. So you can easily divide them. And 16 raised to power -2 can be written as 1 by 256. So after performing the multiplication for the integer part and the divisioning for the fractional part, these are the answer. These are the multiplication results for the integer part. And 1 by 16 is equal to 0.0625, and 1 by 256 is equal to 0.00390,625. After performing the multiplication for the fractional part and adding up the integer part, the result is this. When we add up both the sides, this is the final answer, 3020.0625, which is ultimately a decimal number. How you write the answer? The given number, hexadecimal number, was BCC.10, and it has been converted to a decimal number, that is 3020.0625. Let's see another example. We are given a hexadecimal number containing both the integer and fractional part, EF.B1. Now E is equal to number 14 and F is equal to number 15. While B is equal to number 11. Since 11, 15 and 14 are not valid representation in hexadecimal number, so instead of them they have been substituted by alphabets. So B is for 11, E is for 14 and F is for 15. So how we can convert the given number in decimal number? We have to multiply every digit both in the integer part and in the fractional part with 16. The power of 16 for the integer part starts from 0, while for the fractional part the power of 16 starts from -1. The multiplication process for the integer part moves from right to left, while for the fractional part it moves from left to right. So how we can do it? The given number is EF.B1. This is how we multiply every digit. First digit in the integer part is F. F is equal to 15. So 15 is multiplied by 16 and its power of 16 starts from 0. Next digit is E, but E is equal to 14. 14 is multiplied by 16. The power of 16 is 1. Decimal point is converted with or replaced with plus symbol. First digit in the fractional part is b. B is equal to 11. Here you can see b is equal to 11 and it is multiplied by 16. The power of 16 is -1, and next digit in the fractional part is 1. It is multiplied by 16. The power of 16 is -2. When we clear up the powers, these are the answers in front of you. So anything raised to power 0 is equal to 1. So 16 raised to power 0 is 1. 16 raised to power 1 is equal to 16. While 16 raised to power -1 can be written as 1 by 16, and 16 raised to power -2 can be written as 1 by 256. So after multiplication and divisioning, these are the answers. 1 by 16 is equal to 0.0625 and 1 by 256 is equal to 0.00390,625. After adding the integers part and multiplying the fractional part, the results are this, and we add up all the products. This is the final answer, 239.69140,625. This is a decimal number. How we write up the answer? EF.B1, which was a hexadecimal number, is equal to 239.69140,625, a decimal number. You can see every digit is within the range of decimal number system. If you see the final answer, every digit is within the range of decimal number system. So this is how we convert a hexadecimal number to a decimal number. Method is simple and must be understood to you by now. Here we have completed first conversion for hexadecimal number system. We have performed hexadecimal to decimal number system conversion. And the method was, we need to multiply every digit in the given hexadecimal number with 16. For the integer part, the power of 16 will start from 0, while for the fractional part, the power of 16 will start from -1. The multiplication process for the integer part will move from right to left, while for the fractional part, the multiplication process will move from left to right. Or simply, you can keep in mind, whenever you are given a number having a decimal point, so you need to start the multiplication process right from the decimal point. So one side will lead you towards left and other side will lead you towards right. So this is your assignment. You need to convert the given hexadecimal numbers into their respective decimal number system. Assignment will be soon uploaded on KCMS. You need to attempt the assignment within the due date. Here we come to the end of today's discussion. We have performed hexadecimal to decimal conversion, and that collectively now make 10 conversions, 10 number system conversions that we have performed so far. As I said in the starting, there are a total of 12 number system conversions are there. And so far, we have completed 10 total number system conversions that make 3 conversions for decimal number system, 3 conversions for binary number system, 3 conversions for octal number system, and 1 conversion for hexadecimal number system have been completed so far. We are left with 2 further conversions for hexadecimal number system that include hexadecimal to binary number system conversion and hexadecimal to octal number system conversion that we are going to perform in coming lectures. I hope the process to convert hexadecimal to decimal number system is understood to you. Still, if you have any queries, you can ask me on KCMS or email me. My email address is mentioned here. That is all for now. I thank you all.